sarcomere consisting. Now, this one we call it as a muscle cell. This is muscle cell. The muscle cell is also called the muscle fiber. Both are correct. It is also called the sarcocyte. Now, in the muscle cell, what is present? Many myofibrils are present. This is A band. This is I band. Another I band. The I divides by Z line. The I divides into 2 by Z line. The distance between two Z lines, sarcomere. In a sarcomere, what are the components? Part of I, complete A, part of I. I divides into 2 by Z line. So, in the sarcomere, part of I, complete A, part of I. Now we observe, a sarcomere consists a complete A band plus 2 halves of I bond. This is part of I band, part of I band. So that one we call it as sarcomere distance between two Z lines. In a sarcomere, part of I, complete A, part of I. Now the correct answer is, we go for the next question. T tubule is formed at AI junction in. Now in case of mammals, this is the muscle cell or muscle fiber or sarcocyte. It is covered by plasma lemma called sarcolemma. And this one we call it as A band. And this one we call it as I band. Now the I divides into 2 by Z. The I divides into 2 by Z. The distance between the two Z lines, sarcomere. Now in case of mammals, between I and A, the sarcolemma undergoes folding or invagination. You observe, we are getting a T-shaped tubule. On either side, two cisternae. Okay, one T tubule plus two cisternae. That we call it as triad. Now, between I and A triad. Again, here, the sarcolemma folds. Now we are getting a T-shaped structure. Now again, it is a triad. Now here, in a muscle cell, in a sarcomere, how many triads are present? 2 triads. In a muscle cell, how many triads are present? Many. What is the sarcomere? Place between two Z lines. In a sarcomere, how many triads? 2. In a muscle cell, how many triads? Many. What is a triad? One T tubule, on either side two cisternae. Now here, such triad between A and I, where it is present? Only in case of mammals. Now the answer is, now the next question. The dark band of sarcomere consists of. Generally the students are going to mistake. The sarcomere, in the sarcomere the dark band. Now this is the muscle cell. and this is the I band, and this is A band, and again this is I band, like that they are arranged. And in the center of I, what is present, students? Z. Now between the two Z lines, what is present? Sarcomere. Now here what is the dark band? A. Now the arrow mark indicates the lateral portions of A band. In the lateral portions of A band, what is present? The myosin and actin and troponin and tropomyosin. Actin, troponin, tropomyosin and myosin, all these present in the lateral portions of A band. In the sarcomere, name the band that is much darker, the lateral portions of A. Now based on this information, what is the dark band of sarcomere? No doubt A. Now we are discussing the lateral portions of A. The lateral portions of A consisting actin, troponin, tropomyosin and myosin protein made filaments. Now go for the next question. Read the following statements about the events of muscle contraction and arrange them in a sequence. First we have to observe the statements. Transmission of action potential. What is meant by action potential? Nothing but impulse. Transmission of action potential by T tubule. Release of calcium ions. Arrival of nerve impulse and release of acetylcholine. Students again observe. Release of acetylcholine at motor end plate, END, motor end plate. Reaction of calcium ions with TPC, uncovering of active sites. Reaction between BET, reaction between active site and myosin cross bridge forms actomyosin complex. Now as we observe the sliding filament theory, now this is the motor neuron. This is the motor neuron. The motor neuron brings the motor impulse. Now this is the muscle cell. The space between telodendrons of motor neuron, sarcolemma of muscle cell. This we call it as the motor end plate. Now, as we observe the motor neuron, these are dendrons. The dendrons receive impulse. Here the impulse is named as action potential. Now, the impulse received by dendrons then goes to cyton, axon, telodendrons, motor end plate. Now, what is excited? The sarcolemma. Then what is excited? The T tubule. Then what is excited? The cisternae. Now what will be released? The calcium ions. The calcium ions are attached to TNC. Now because of the calcium ions, as we observe, this one we call it as the thin filament. On the thin filaments, what are present? The active sites. These dots are called active sites. Whenever the muscle is at rest, the active sites are covered by tropomyosin. Whenever the muscle is at rest, on the thin filament, we are unable to observe the active sites. Now, the calcium ions release. The calcium ions remove the tropomyosin. The calcium ions remove the tropomyosin. Now automatically what are exposed? Active sites. Now with this active site, what is attached? The myosin. Myosin plus active site. In the active site mainly what type of protein is present? Actin. So myosin plus actin unite to form actomyosin complex. This is also called the cross bridge. So that based on this information, what is the correct option? Arrival of nerve impulse and release of acetylcholine at motor end plate. Transmission of action potential by T tubule. Release of calcium ions. Calcium ions bind to TPC. Now active sites are exposed. Reaction between active site and myosin will form a cross bridge. Based on this, the answer is the 1. Now we go for the next question. Assertion. During contraction, the size of sarcomere. During contraction, the size of sarcomere in a striated muscle is reduced without reduction in the size of thick or thin filaments. Now this is the muscle cell and this is A band. From the A band, what type of filaments will arise? The thick filaments. And this is I band and this is I band. From the I band, what type of filaments will arise? Thin filaments. In the center of A band, what is present? You have to observe H zone. In the center of H, what is present? M line. Now during the muscle contraction, what is going to happen? The thin filaments slide on thick filaments. Again repeating. During muscle contraction, the thin filaments slide on thick filaments, so that both thick and thin filaments enter into the middle part of A band. Again repeating. During muscle contraction, the thick and thin filaments enter into A band up to the middle part. That means up to H zone only, but not up to the M line, so that there is no change in the A band. So here during contraction, the size of sarcomere in a striped muscle or striated muscle or voluntary muscle or skeletal muscle is reduced without reduction in the size of thick or thin filaments. Reason: during muscle contraction, the thin filaments slide past over the thick filaments and are pulled towards the center of sarcomere, but not up to the M line. The thick and thin filaments enter into A band only up to H zone, but not the M line. So there is no change in the A. So both are correct. R explains A. Now we go for the next question. Hensen's disc. Now what is the Hensen's disc? This is A band. In the center of A, what is present? H zone. That is called Hensen's disc. Hensen's disc in the sarcomere is darker than I band, because as we observe the I band, in the I band what are present? Actin, troponin, tropomyosin. These proteins molecular weight is very less. In the A band, mainly what is present? Myosin. In the H, what is present? Myosin. In the M line, what is present? Myosin. No doubt, the myosin protein molecular weight is more than that of molecular weight of actin, troponin, tropomyosin. So that the A, the H, the I are much darker than that of the parts of I. That means I and Z, etc. Now here, what is the answer? Presence of the myosin filaments. Now we go for the next one. Study the following statements and choose the correct one. First one, walk along mechanism is the basis of sliding filament theory. Now, the sliding filament theory proposed by Hugh, Huxley and Hansen. In the sliding filament theory, the thin filaments slide on thick filaments. That means along with the thick filaments, what are moving? The thin filaments. So it is called walk along theory. It means along with the thick filaments, the thin filaments are walking. So walk along mechanism is the basis of sliding filament theory. So the statement 1 is correct. Second, sliding filament theory was proposed by Hugh, Huxley and Hansen. Third one, triad systems are present in M line. That is wrong. In case of mammals, we discussed already. In mammals, the triad present between I and A. Other than mammals, that means in Pisces, amphibians, reptiles, aves, where triad is present in the Z line. But here what they gave? Triad systems are present in M line. That is wrong. Fourth, the tail of myosin molecules are present towards H zone. And now, this one we call it as the A band. In the center of A band, what is present? H. Now from the A band, what will arise? The thick filament. TH means thick filament. Now, along the length of thick filament, what is present? The myosin molecules are present. Now these are myosin molecules. Now this one we call it as the head of myosin molecule. And this one we call it as the neck of myosin molecule. And this one we call it as the tail of myosin molecule. Now you observe the diagram. The tail of myosin molecule is towards the H zone. So the fourth one is correct. Here what is the wrong? Only the third statement. We go for the next question. In the sarcomere, the number of teeth tubules present in the striated muscle of man is 2. Now this one we call it as the muscle cell, and this one we call it as A band, and this one we call it as I band, and this one we call it as I band. In the center of I, what is present? Z. Between two Z lines, what is called? The sarcomere. Now between I and A, what is present? One teeth tubule, two cisternae. Here again one teeth tubule and two cisternae. So in a sarcomere, how many triads are present? 2. In a muscle cell, how many triads are present? Many. Here what is the assertion? In a sarcomere, the number of teeth tubules present in the striated muscle of man is 2. That is correct, because the reason in mammals the triad system is present at the junction of A and I. So in a sarcomere, how many triads? 2. So both are correct, or he explains A. Now we move for the next question. Joint between carpal and metacarpal of thumb. Now as we observe this part we call it as the wrist. In the wrist what are present? The carpels. Now these are called the metacarpals. Now these are called metacarpals and these are carpels. Now as we observe the thumb, the joint between carpel and metacarpal of thumb we call it as saddle joint. So because of this joint, the thumb enjoys free movement when compared to that of other fingers. When compared to that of thumb, the remaining fingers does not move freely. When compared to that of the remaining fingers, the thumb enjoys the greater movement. Because what type of joint present between carpal and metacarpal of thumb? That we call it as the saddle joint. The answer is. Now we go for the next question. Assertion. Friction in a movable joint is less. Now as we observe the movable joint, this one we call it as one bone and this one we call it as another bone. In a joint how many bones are present? Two bones are present. Now these two bones are connected by elastic ligament. Now this entire joint is present in articular capsule. Now the articular capsule inside lined by the synovial membrane. Now this one we call it as synovial membrane. Now the synovial membrane secretes synovial fluid. Now this is the synovial fluid. As long as synovial fluid is present, the bones do not get any friction. So here the friction in a movable joint is less. In a movable joint, the friction between the two bones is very less because the articular capsule, the joint is present in an articular capsule. The articular capsule is filled with what type of fluid? Synovial fluid secreted by synovial membrane. So in a movable joint between two bones, the friction is very less. So both are correct or explains here. Now we go for the next question. Joints of phalange. Now as we observe, all these are the fingers. In the forelimb, these are called fingers. In the hind limb, they are called the toes. But what is the common word? Digits. Now, as we observe the fingers, in the fingers the bones are present. The bones present in the fingers are called phalange. Now, in between phalange, what type of joint is present? Hinge joint. Now, as we observe the bones in the fingers or toes, they exhibit the movement only in one direction. If it exhibits this movement, the angle decreases. If in this stage, the angle increases. So the joint in the phalange exhibit movement only in one direction. That is called hinge joint. The other name of hinge joint. Now the answer is ganglion. Now we go for the next question. A joint in which a bony projection of one bone fits into a bony socket of another bone immovably. Now this is one bone. This part we call it as bone. Now this is the projection of a bone. Now this is another bone. And this is the socket. Now the bony projection of one bone fits into the socket of another bone. Now this is, as we observe, this is a socket and this is a bony projection. The bony projection inserts into the socket of another bone. There is no free movement, immovable. That we call it as gomphagus. The answer is. Now we go for the next question. Peg-like odontoid process is developed from. Peg-like odontoid process is developed from. Now as we observe the neck region, this part we call it as neck region. In the neck region, the vertebrae are called cervical vertebrae. In almost all mammals, how many cervical vertebrae in the neck region? 7. The first cervical vertebra is called atlas. The second cervical vertebra is called axis. Now, this is the axis, second cervical vertebra. It has a projection called odontoid process. Now, this is the ring-like atlas. This we call it as atlas. On the atlas, what is present? The head is present. So, as we observe this condition, now this one we call it as the axis. This is odontoid process. Now, as we observe odontoid process, on odontoid process, the ring-like atlas rotates so that we can move our head in the rotatory motion, because on the atlas, what is present? The head. The atlas is a ring-like vertebra. It freely rotates on odontoid process of axis. Now here, peg-like odontoid process is developed from what type of vertebra? Second. That we call it as axis. Now the answer is the axis. Now we go for the next question. Shoulder joint. What is meant by shoulder joint? Now as we observe this one, we call it as shoulder joint. Now here the pectoral girdle is present. In the pectoral girdle, a cavity present called glenoid cavity. Now this bone we call it as humerus. The head of humerus fit into glenoid cavity so that we can move our forelimb in all the directions. So it is an example for the ball and socket joint. It is also called the multi-axial because we can rotate this in all the directions. So it is called the ball and socket joint, or it is also called the multi-axial. What is the shoulder joint? Joint present between the head of humerus and glenoid cavity. Now here the answer is multi-axial. Next question. The digital formula of hind limb of rabbit. The digital formula of hind limb of rabbit. Now this part we call it as hind limb. In the hind limb, how many toes are present? That is 4 toes. This is the first toe absent. This is the second toe, third, fourth, fifth. How many toes are present? Only 4, because the first one is absent. Now, in the second toe, how many phalanges? 3, 3, 3, 3, 3. Now here, this toe absent. So, 0, 0, 3, 3, 3, 3. Now, what is the answer is? Now, we go for the next question. Floating ribs of rabbit. Floating ribs of rabbit. Now, this part we call it as the sternum. This part we call it as sternum. Where it is? On the ventral side of thorax. This part we call it as sternum. Now, as we observe the vertebral column, the vertebral column has the vertebrae. Now, this one we call it as the vertebral column. The vertebral column has the vertebrae. Now, as we observe, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, and 13th. Now, the first pair of ribs attached to sternum. second pair attached to sternum, third pair attached to the sternum, fourth attached to the sternum, fifth attached to the sternum, sixth attached to the sternum, seventh attached to the sternum. Now what about the eighth and ninth? The eighth and ninth attached to seventh. The ribs that are attached to sternum are called true and remaining are called false. Eighth and ninth attached to the seventh. Now 10th one, 11th one, 12th, 13. They are not attached to the sternum. They are also false ribs and they are freely floating. Here what is the question? Floating ribs of rabbit are 10th, 11th, 12th or 13 also. So 10th, 11th and 12th pairs of ribs. Now the next question. Arrange the correct sequence of forelimb bones from proximal to distal. Now this is the forelimb. This is the proximal part and distal part. Now arrange the bones of forelimbs from anterior to posterior or proximal to distal. Now here the first bone is the humerus, followed by radius ulna, and here carpels, and these are metacarpals, and in the fingers what are present? Phalange. So arrangement of bones: humerus, radioulna, carpels, metacarpals, and bones in the fingers are called phalange. So based on this, the answer is. Now we go for the next question. Anterior margin of cranial cavity. Now this part we call it as the cranium. The cranium is also called the brain box. Now as we observe the cranium, this is dorsal side, this is ventral side, and these are lateral sides. This is posterior and anterior. The anterior end of cranium is covered by what type of plate? Cibriform. Now the answer is. Next question. Study the following and choose the correct one. The skeletal system formed from the body wall is visceral skeleton. The skeletal system formed from the body wall, somatic skeleton. The skeletal system formed from the pharyngeal wall is somatic. Now here, the skeleton derived from body wall is somatic. The skeleton derived from the pharyngeal wall is visceral skeleton. Again repeating, the skeleton derived from the body wall is somatic. The skeleton derived from pharyngeal wall, that is visceral skeleton. So based on this, the correct answer is. Now we go for the next question. Now assertion. The skull of rabbit is trophy basic. Now what is meant by trophy basic skull? Now as we observe the rabbit, this part we call it as the skull. At the base of skull, two occipital condyles present. Two occipital condyles. How many occipital condyles? Two. So it is called dicondylic. And this one we call it as the orbit. Now here what is the assertion? The skull of rabbit is trophy basic. Reason: the skull contains an interorbital septum between optic capsules. Now this is the orbit. In the orbit, the optic capsule present. The dotted line indicates the optic capsule. Now the optic capsules connected by interorbital septum. So the skull we call it as trophy basic skull. We have to discuss the remaining in the next class.